In today's lesson, we are working on linear equations. Our objectives will be to be able to find the slope between 2 points, to identify the slope and the y-intercept from an equation and a graph, to graph a linear equation, and to write the equation of a line from a graph. What are linear functions? A linear function is any situation that changes at a constant rate. For example, this is a description of a linear function. You get $5 each week. That is a constant rate of change. Every week, $5. Over here on the graph, this is an example of a line, and a line changes at a constant rate. For as the line goes up, it also increases going up and moves to the right at the same rate. Here is a table. This table is showing a constant rate of change. For every x value that increases or goes up by 1, my table is increasing on the on the range of an increase of 2 as well, or my output. Let's take a look at the parts of a linear function. First of all, when we talk about our linear function, we need to talk about slope. Remember that slope is the rate of change, and there are 4 types of slopes. We have the positive slope, where our line is going up and to the right. We have our negative slope, where our line is going down to the right. We have a slope of 0, which is a horizontal line. And we have our slope that is undefined, which is our vertical line. Remember, when we're taking a look at slope, to see if it's positive or negative, we read from left to right to determine whether it's going up or down. 0 slope, remember, that's like a floor, easy to walk on, so the slope is 0. And to remember the difference between the two, when you're talking about a slope that's undefined, a vertical line, I give an example. Can you, without any assistance, walk straight up a wall? Not possible, obviously because of gravity, and we're not Spider-Man, we don't have suction cups on our feet. So we can think of it as being impossible or undefined. Now the slope is going to tell us the angle and the direction of the line. The angle would be determining the steepness, and the direction meaning if it's up, positive, negative, 0, or undefined. Remember that slope is the rise over the run. How is my line changing up and down compared to across, left to right? And we can determine slope by using 2 points, the difference of the y-coordinates of 2 points, and remember that we use the y's on the top, the y's are the rise, divided by the difference of the x values of the 2 points, which is our run, and our x value, remember, goes left to right, so that's our run. The next part of a linear function is the y-intercept. The y-intercept is the starting value in any situation. It is the point where the line crosses the y-axis. Please remember, when you cross the y-axis, that the x value is always 0. And we list the y-intercept as a coordinate on the coordinate plane as 0, the value of the y-intercept b. So in a linear function, we recall that the equation in slope-intercept form is y equals mx plus b, where m represents the slope and b represents the y-intercept. So in this particular example, negative 2/3 represents my slope and 4 would be my y-intercept. In this particular example, if we're looking at this graph and we want to find the slope, we want to count the rise over the run. So when we do that, we start at any point that is on the line and we count how many boxes do we rise, go up. That happens to be 2. And then we go 1 box over, 1 unit over to the right, which is a positive 1. So my slope is 2 over 1, which we can simply write as 2. We also can use the example of finding any 2 points on the line and subtracting the y values and the x values to find our slope. It doesn't matter which point we use as our y2 or y1. It can go in any order as long as we subtract the same way with our x values. So I'm going to start with my 7, and I'm going to subtract the 8, which is subtracting the y values. Remember, if this is my x values and my y value, my x value and my y value. Since I began with this point for my y value, I must also start there for my x values. So I have 3 minus -2. 7 minus 8 is -1. 3 minus -2, remember minus a negative is plus. 3 plus 2 would be 5. So in this particular case, the slope of the line containing these 2 points would be -1/5. Let's do some examples of finding slopes of lines. When you're finding the slope of a line, you may find any 2 points where the line is crossing at integers, which means right at the corners of boxes. We don't want to have to deal with any fractions or decimals. And we count the rise over the run. So if I start at this point, I want to know how many units do I go up or down. And I'm going to go 1 unit up, and I'm going to go 2 to the right, which means I had a rise of 1 and a run of 2 units. The slope of this particular line is 1/2. In this example, you may pick any 2 points, and I want to know how do I get to the next point on the right. In order to get there, I'm going to go 1 unit down and 1 unit to the right. So my slope is going to be down 1 unit, which is -1 over 1 unit to the right. Simplified is -1. Let's practice calculating slope by using 2 points on the coordinate plane. Remember, we're going to subtract the y values. So I have 3 minus 5, and I'm going to subtract the x values in the same order. So I start with -6 minus -5. That's going to equal my slope. 3 minus 5 is -2. -6 minus -5, we change that to +5, would give me a -1. Simplified, my slope will be 2. If you decide to go the other direction and took 5 minus 3 and -5 minus -6, you'll get the same result. Let's practice the next example. Here is my x and y values for each of the points. Let's subtract the y values. 8 minus 8, and then we'll do the same order, 0 minus 2. 8 minus 8 is 0, and 0 minus 2 is -2. Simplified, 0 divided by any number except 0 is 0. So this has a slope of 0, and that would be an example of a horizontal line. I'd like to do one more example. Let's say we had the point 5, negative 5, 3, and then we had the point negative 5, 6, and I wanted to find the slope. So I'm going to subtract my y values, and then I'm going to subtract my x values. So I'm going to take 3 minus 6, and then negative 5 minus negative 5. 3 minus 6 is negative 3, and negative 5 minus negative 5 becomes plus 5, and negative 5 plus 5 is 0. Remember when we've been working with fractions and first learning about them, we knew that we can't have 0 in the denominator of a fraction. Negative 3 divided by nothing is not possible. So since we can't have 0 in the denominator of a fraction, this slope would be undefined, and this would be the slope of a vertical line. Let's practice writing equations from graphs. So there's two things we need to do. First of all, it would be great if we could find the y-intercept, which is where my line is crossing the y-axis, and also another point on the line so we can find the slope. So in this example, my y-intercept, where I'm crossing the y-axis, is at the point 0, 7. And my slope, m, is the rise over the run. So I'm going to count, beginning at my y-intercept, I'm going to count 2 up, positive 2, and 1 to the right, positive 1. So that's going to be 2 over 1, which equals 2. So when I write my equation in slope-intercept form, I have y equals my slope 2x plus 7, which means my y-intercept is at a positive 7. In my next example, I'm first going to find my y-intercept. But this is an example of a vertical line, which means that we are not crossing the y-axis, so we don't have a y-intercept. Secondly, my slope is undefined. I don't have, because it is a vertical line, my slope is undefined. So what I do want to know is what would I be special about a vertical line? Well, what's special about a vertical line is no matter where I pick points on this vertical line, my y values are constantly changing because I'm going up and down infinitely, but my x values are remaining the same. From my origin, I have 1, 2, 3, 4, 5 to the right. So to write the equation of a vertical line, the x values are always going to be the same, in this case 5. We don't put a y in this equation because our y values are infinite. Let's go down to G. G is an example of a horizontal line. First of all, we're crossing the y-axis at 1, 2, 3, negative 4. But what we want to take a look at is that the x values are infinite. The x goes infinitely from left to right. But what we do know is no matter where I pick a point on this particular line, my y value is always the same. It's at negative 4. So when we write the equation of a horizontal line, it will always be the pattern y equals and then the value, negative 4. Let's practice now taking our equation and graphing from there. So in our first example, what we notice is that our y-intercept is at the value -2. So that's the first thing we're going to do when we graph, is that we use the y-intercept as our starting point. So we want to put a dot on our coordinate grid, a point on our coordinate grid at -2. Then the value of the number in front of the x, called the coefficient, is our slope. So we'll put our pencil on -2, our y-intercept, and from there we'll do our slope, which is rise 1 and run 5. 1, 2, 3, 4, 5. That's where my next point should be. And then we can go again, up 1 and over 5. And then we can draw our line from there. In our next example, we have y equals -7. This is an example of a horizontal line. We know that because we don't see an x value present. We just have a y and it's equal to a number. So in order to draw the horizontal line, we're going to find where y is equal to -7. And then we're going to draw our horizontal line all the way across at y equal to -7. Sorry, I need to draw that line a little bit straighter, so at -7. Then we're going to move on to the next one. Whoops, my line's a little crooked, but we get the idea. X equals 2. In this case, we don't see a y value present. So we know that this is an example of a vertical line at +2. So we're going to count to +2, and then we're going to draw our vertical line right along where x is equal to 2. Alright, so let's review. The y-intercept is the point where the line crosses the y-axis and is written as 0, b. b representing the value where it crosses. Our y-intercept form, called slope-intercept form, is y equals mx plus b, where m is slope, which is the rate of change, and the y-intercept is our starting value. Slope is the rise over the run, and it can be calculated by subtracting the y values and then subtracting the x values. It is the rate of change. Please remember to do the reflection.